2014 question number 3 starts with this graph here of f, and they give us the equation for g of x being an integral of f. Make sure as you perceive this question you know the difference between the graph of f and the function g of x. One is a straight up graph, the other one is an integral equation. Now, with that being said, part A is asking us to evaluate straightforward what's g of 3. Well, they give us g over here, and I see it's the integral from -3 to x f of t. You should be able to understand what an integral is. If I'm plugging in for x here, over here, right, g of x, x over here, and 3, it's simply going to be the area, when I plug in 3 here, from -3 to +3 of f. Well, where is f? F is right here. So I'm going to take this point, -3, starting right here, all the way up to +3, which is right here, and I'm going to find the area in between. Now for this case, you have to know that area that's above the x-axis is positive, and anything below the x-axis is negative. So I would write it as this. G of 3 is the integral from -3 to -3 to +3 f of x, or f of t in this case. And the area of this big triangle, right, it's 5 units long by 4 units tall, divide by 2 because it's an area of a triangle, and I get 10. And then the area of this small triangle right here, 1 unit long, 2 units high, that's going to be 1 divided by 2, but it's below the x-axis. So I'm going to subtract this small piece from this big piece, which is why I have 10 minus 1, my answer is going to be 9. Now this is a 1-point question, and you just get the point from the answer. It should be very much a free point, because all you have to do is understand what an integral is, and knowing that it gives you the area under the curve, as well as positive and negative. Part B, it's asking us to find when the equation of g, or the graph of g, is increasing and concave down. Now, you have to go back to your basics. What does it mean for a function to be increasing and concave down? Well, for it to be increasing, the first derivative has to be greater than 0, and for it to be concave down, the second derivative has to be negative. Well, what's the first derivative of g if g is an integral? You should know that this is going to be what they call the fundamental theorem of calculus. All it is the derivative of an integral function, when you take it, is going to be, you swap out, if this is f of t, you're going to put whatever is in here in for this t. So this was 5x, I'll be my integrand right here, this middle part would be f of 5x, but because I just have x, it's going to be f of x. But also times the derivative of whatever this was. So if this was 5x, I would replace and make this f of 5x times the derivative of 5x, which is 5. In this case, because I just have an x, my derivative I'm going to be multiplying out is just 1. In other words, my derivative here of f prime is going to equal the actual graph, and that's what I have right here. So derivative of g, is equal to just f of x, because again, with the derivative of an integral function, we'll undo the integral and just leave you with f here. So the second derivative of g is going to be the first derivative of x. Now the question is, when is g increasing and concave down? Well, g prime needs to be positive, and if g prime equals f, I'm looking at when the height is positive. And for my second derivative, I'm looking at when is the slope positive. Some things to remember: if I'm 1 derivative away, I'm looking at slope. If I'm 2 derivatives away, I'm looking at concavity. But if it's a match, I'm looking at height over here. So my first derivative is f. I'm given the graph of f, so I'm now looking at height. When is height positive? I marked it down here, but you don't even need to make your own chart. You can just look at here. The height here is positive from here, here, and here. So part of my answer is going to include this. Now, I'm going to look at my second derivative. When is g double prime or which is equal to f prime. In other words, f prime is one derivative away from f. So if I'm one derivative away, I'm looking at slope. When is slope negative? That's going to be right here and here. Again, you can write that out and organize your thoughts, but eventually you're going to combine the two. The point where, or the portion, let's say, where it's both increasing, or the height is positive, and concave down, where the slope is negative, is going to be here and here. Or just simply from -5, to -3, union 0 to 2. Now you have to justify your answer, and you're going to say simply because the derivative of g is simply f, because again, fundamental theorem of calculus, the derivative of an integral will undo the integral, and you can just say that it's positive and decreasing on this particular interval. Now this question was worth just simply 2 points, 1 point for the actual answer here, but another point for the reason. You have to understand, again, the fundamental theorem of calculus, undoing an integral and getting the function at the end. Part C should be, again, a fairly straightforward and easy one. We're asked to find the derivative of h at 3, and we know automatically when we see this ratio, we should think quotient rule. Now, an easy way to remember quotient rule is just the small kind of jingle you can say to yourself. You can write the derivative using quotient rule as low d high minus high d low, draw the line and square below. What do I mean by that? Here's what I mean. Low, 5x, d high, the derivative of g, minus high, just g plain, minus d low, times d low, or just 5. Draw the line and square below, 5x squared. That's going to be your formula. This portion right here is just worth 2 points. So without even finding or even plugging in g prime of 3, you already have 2 points. That's the majority of the points you're going to get for this question. Now, as far as evaluating, it's straight simple. 5 times 3, 15. G prime of -2. Well, we said before that g prime, or the derivative of g, is just equal to f itself, the undoing of the integral. So g at 3 is going to be -2 over here, minus g plane of 3, the basic function, which we did before in part A. Part A asks us to find g of 3, so we can use that value here, 9 times 5. Draw a line, square below, 15 squared, you get 225. You can simplify and you get -1/3. Now again, only 1 point for the answer, but you get most of your points from this equation right here. Part D, finally, it's asking us to find the derivative, or the slope of the tangent at this point, x equals -1. You should know automatically this is going to be a chain rule. So it's going to be the derivative of the outside, keep the inside the same, times the derivative of the inside. A lot of students will make the mistake of just taking the derivative of the outside, but they forget to multiply by this inside. It's simply take the derivative of the outside and then multiply by the inside. You plug in 1 here for both here and here, and finally get 6. Again, most of your points will come in for this equation here, 2 points, and only a point for the actual answer.